In computer networking, a minimal pause may be required between network packets or network frames, depending on the physical layer protocol or encoding used. The pause may be necessary to allow for receiver clock recovery, permitting the receiver to prepare for another packet, e.g., powering up from a low power state, or another purpose. Ethernet devices must allow a minimum idle period between transmission of Ethernet packets known as the interpacket gap, IPG, interframe spacing, or interframe gap, IIFG. A brief recovery time between packets allows devices to prepare for reception of the next packet, while some physical layer variants literally transmit nothing during the idle period. Most modern ones transmit a constant signal and send idle symbols. The standard minimum interpacket gap for transmission is 96 bit times the time it takes to transmit 96 bits of raw data on the medium, which is 9.6 microseconds for 10 mbit per second Ethernet, 0.96 microseconds for 100 mbit per second. Fast Ethernet, 96 nanoseconds for gigabit Ethernet, 38.4 nanoseconds for 2.5 gigabit Ethernet, 19.2 nanoseconds for 5 gigabit Ethernet, 9.6 nanoseconds for 10 gigabit Ethernet, 2.4 nanoseconds for 40 gigabit Ethernet, and 0.96 nanoseconds for 100 gigabit Ethernet. Some manufacturers design adapters with a smaller interpacket gap for slightly higher data transfer rates, which can lead to a high rate of detected collisions. An example is Intel Ether Express 100B. On reception, some interpacket gaps may be smaller due to variable network delays, clock tolerances, and the presence of repeaters. 10 and 1000 mbit per second only. For 40 and 100 gigabit Ethernet received IPG can be reduced to a period of 8-bit times 1 byte. For 2.5, 5, 10, and 25 gigabit Ethernet received IPG can be reduced to a period of 40-bit times 5 bytes. For gigabit Ethernet received IPG can be reduced to a period of 64-bit times 8 bytes. For fast Ethernet received IPG reduction is not specified. Standard is 96-bit times 12 bytes. For Ethernet received IPG can be reduced to a period of 47-bit times fiber channel. For fiber channel, there is a sequence of primitives between successive frames, sometimes called interframe gap as well. The minimum sequence consists of 6 primitives. Idle, R underscore RDY, R underscore RDY, idle. Each primitive consists of 4 channel words of 10 bits each for 8B, 10B encoded variants. 128 gbit per second, equivalent to 4 data bytes.